Hi, I'm David Marshall. So there's loads of XNA tutorials out there. Why am I making yet another one? Well, programming isn't just a science, there's a little bit of art to it as well. And everyone codes things a little bit differently. There's always something new to learn from each of them. They've all got different techniques, levels, styles. That said, I'm going to start by assuming you know a bit about computers in general and about computer games in particular, but not necessarily any C# or even programming in general. Programming isn't rocket surgery, but it is all about problem solving. No matter how many tutorials you watch, nobody can ever tell you how to do everything you could ever want to program. All we can show you are the tools at your disposal and help you to understand how to decide which of them to use. For example, I'm not going to leap right into object-oriented programming like some tutorials do. I'm not even going to do some stuff that's actually kind of important for a real game until much later, like managing the window resolution or using precise timing. I'm a bit more interested in just getting things up and running. Before I do that though, I'm going to show you how XNA works so that we're on the same page when I start talking about things like declarations, updates, that sort of thing. If you just want to get a program running, you could just skip this tutorial entirely. Anyway, let's start our first project. I'm going to load Visual C# 2010 Express, which is the free version of Visual Studio for C#. The 2010 version is the version you must use if you want to do any XNA version 4 programming. A lot of the stuff I'll show you is also usable in other versions of XNA, but not all of it, so bear that in mind if you're not on the same version as me. And those links will tell you how to find the software you're going to need if you want to program in XNA. So first, once you load up Visual Studio, you want to go to the File menu and select New Project. Make sure you're in the XNA Game Studio 4 templates and choose a Windows game. Then you can browse for where you want the game to go. Quick note, if you're on a network, be aware that XNA uses .NET and there may be security restrictions which will stop you running a .NET program over your particular network, so check that out first. In this case I'm just saving it to the C drive, so everything should be fine. And I'm going to name this one Tutorial 1. When you click OK, it may take a few moments to create your solution, and then it will appear on this sidebar on the right hand side called the Solution Explorer. Solution Explorer shows all the files inside your whole solution. There's C# code ending in .cs, there's an icon for your game, a thumbnail image, and a folder containing the project properties. All of these are inside another folder that has the same name as your project. There's also another folder which has the same name but followed by the word content, and that's where you should put all of your graphics, sounds, 3D models, fonts, etc. And both of those are stored inside another folder which is just the entire solution. I think actually I'm going to show you that folder in Explorer if I can remember where I put it. Probably under Visual Studio Projects. There it's there. So that's the actual solution folder, and then inside Tutorial 1 you've got the folder that contains all of your code and bits and pieces, and then the folder that contains all of your content. So if you ever want to make backups or give a copy to somebody, make sure you copy that entire folder. And for the same reason, try and avoid for the moment using open file or save as, because those will only work with individual files and not the whole solution. Use save all and then close down Visual Studio and copy that entire folder if you have to. I recommend doing it that way until you know XNA inside out, because if you save a file to the wrong place, load the wrong file in, things can easily get mixed up, go missing, or get linked to the wrong place, duplicated, whatever. Try and avoid it in general. Now, there's two C# code files in here, program.cs and game1.cs. And if you look at game1, a couple of important things here is, first of all, there's a namespace, called in this case Tutorial 1. A namespace is just a container to keep things together so that they can talk to each other without having to use one of these things, the using command. And all that's in all that's in program.cs is something that runs game 1. That's its sole purpose in life. So for the most part, you can pretty much ignore it and just work in game1.cs. Now if you look at that, it starts with a lot more using commands. That's because it uses things like the audio framework so that you can load in sound effects, the content framework to let you get access to things in this folder, and so on. And that's all the stuff that XNA provides for you. And it's in the same namespace. The key here is just to make sure everything's in the same namespace, or else they won't be able to communicate. The curly bracket underneath, technically it's called a brace, but everyone just calls them curly brackets. There's a closing curly bracket at the end of the file as well, which matches it. In fact, if I click on it, you might just be able to see that it turns a slightly darker grey, and so does the matching bracket at the top. So that way you can check which bracket matches what. So everything inside those two brackets is part of tutorial 1 namespace. And the first thing inside the namespace is a class called game1. It said I'd avoid object orientation, so let's just say for the moment everything that's in your game should be inside those brackets, the second set of brackets. Also the green stuff that you see, which is after a couple of slashes, that's called a comment. It doesn't actually do anything except give you some information. The computer ignores them when it's compiling the program. So after the class declaration, we have some other declarations. We've got graphics device manager and sprite batch. Each of these are classes themselves. A class, normally 9 times out of 10, a class itself doesn't actually exist. What it's there for is to let you create objects of that class. So we can use this graphics object to change the resolution, for instance. And we can use this sprite batch object to draw things, but we can't use that one because it doesn't actually exist. That one's only used to create the object. And by default, the sprite batch object, the object of the sprite batch class is also called sprite batch with the lowercase s. Thumbs up for creativity, Microsoft. And C# is very picky about capitalization, so you must use the right one, the right capital or lowercase s, or you'll get the wrong object. So next we have a line saying public game1. This is what's called a constructor because it's where the actual game itself is created. We set up the graphics and we set up the content pipeline so that we can load things from the content folder in the Solution Explorer. Then we have the initialize function, or method I should say. I keep saying functions, but technically they're methods which are slightly different. To you and me there's not much difference. Oh, and also incidentally, if you don't like these comments, you can just click the minus sign to hide them, or usually you can be safely deleted as well. So the initialize method is used to set up all the objects in your game, like screen resolution, lives, variables, etc. Before the game starts. There's also a line that says base.initialize. And that's something to do with object orientation, so I'm going to gloss over that, except to say don't delete it, leave it in there. So after that you've got the load content method, and this is where you should load stuff from the content pipeline over here. Everything in here is just a file, you can't actually use it yet. You need to load it in to the load content function before you can actually do anything with it. So images, sounds, all that kind of stuff. And by default you should see that XNA sets up the sprite batch in here, because sprite batch is connected to your content. You use sprite batch to draw text and to draw images. Next we have the unload content function. It starts off empty, and generally speaking you should keep it that way. So unlike languages like C++ or Pascal, C# has a built-in memory management system called the garbage collector. If you don't dispose of content properly, C# will do it for you. You should only use this method if you manually allocate memory, and that's even more advanced stuff, so for now it should definitely be empty. Now we got into the meat and bones of XNA, which is the update function and the draw function. I'm going to simplify how it works slightly, but essentially what happens is that XNA will loop round and round over and over 60 times a second, running both the update method and the draw method. That means every roughly 16 milliseconds it will run both of these. The first one, update, is where the game logic updates. It's for things like movement, physics, collisions, and so on. This one, draw, is where you should put any code that draws things on the screen, or is it to do with visualization. Now here's how that looks in visual form. I'm going to have to step through to get back where we were in the PowerPoint. So first you've got the main function in your program.cs file. Next, the declarations inside the game namespace, beg your pardon, followed by the initialization and then the load content method. And then what you'll have is the update method, then draw method, update, then draw, update, then draw, over and over, many times until the program decides to exit. And that's when we go to the unload content method. The update function itself starts with just one real piece of code, which is something that checks the Xbox controller or the Xbox gamepad, checks the status of the gamepad for player 1. And it looks at the back button on the gamepad, and if that button is pressed, then this game will exit. Very handy if you have an Xbox controller attached, not so much if you don't. You can of course use a keyboard or a mouse instead, but the one that comes as default when you create a new project is gamepad. And there's also this base.update. As you guessed, you should ignore that for now, but don't delete it. The draw function is also pretty basic to start with. It clears the screen in a lovely cornflower blue colour, which is light blue to you and me, and then it does base.draw. You know what to do there. So if I run the program in debug mode, which is this little green arrow, or you can press F5 on the keyboard, as you can see from the tooltip, all it does is create a program which, when it runs, clears the screen in a lovely light blue colour. But the last thing we're going to do is to prove to you that those things all did happen in the order I just showed you. So to do that, I'm going to step through the program one line at a time using a thing called a debugger. And you can do that by pressing the F11 key. And then the program will actually start, and you'll see a yellow line indicating which line is about to run. So as you can see, the first thing it goes to is the main function. It then creates the game inside the namespace, runs the game, which consists of initialization, loading of content, and then we have an update. You can have seen the screen appear there briefly, and then a draw, and then back to update, and so on. When you've had enough of that, you can press the stop button, which is this blue square. And that's pretty much how the architecture of XNA works. Next time, I guess I'm going to have to show you how to make it actually do something useful. So see you then.